up here is a double series. 100 strands of beads. Be awesome, I think. Man, wire is not friendly, dude. I do want to say goodbye. Hopefully I remember. I should probably take initiative. What do I mean by that? Let's see here. What I mean is, should probably call to them. And wait a minute. Okay. All right. We're gonna have to boost this up because that's hurting my back.
Got it.
Or I gotta get down on my knees. One or the other. Oh man. Okay.
You got to work that squat.
Yeah. All right. This is a travesty. This is a mess. It's not gonna start a fire or anything, but it's messy. All right, we're gonna get a quick look at the double trigger coil real fast. So we're gonna do 6 volts. Excuse me, bro. Hear that?
Yeah, that's pumping up.
Heck yeah.
If anybody has any questions, drop them in the comments and we'll be able to read them out loud and be interactive.
So, what we have here, just a quick description. We have 2 coils that both have a trigger in them. There's 32 gauge, 333 turns. Then each strand of 26, there's 2 in each. It's hooked up individually, parallel. And they're also 333 turns. And then the cool part about it is they're set and offset. So it's hitting twice virtually every time it spins. You get that set and that offset. So that's pretty cool. I don't think this is functioning right. This Hall effect. It's not supposed to be on like that. I don't think. Maybe.
Maybe it's taking 5 volts from it.
Well, yeah. I mean, but I don't remember the light like being on.
Okay, got it.
But here, let's get it off of this thing. It's on. Wow, it's on there pretty good. Maybe we're just gonna tilt it on its side like that. And that's on there pretty good now too. And that was for the other rotor that I just put in the closet. And it's not even gonna reach. I'm gonna have to hook up a whole nother power supply just to do this. And that's alright. I got it. I got one right here, man. This one's fresh.
Fresh power supply.
It might be worthwhile for me to unhook that from the power distribution though. I'm gonna need another power distribution. How did I do it before I used power distribution? I think I just used diodes. and hook a bunch of connections up to the single diode, waiting for it to explode.
Yeah, nice.
Hey Paige,
Hi.
what's up? Leaving?
Yes.
Okay.
Go look at his room.
Ooh.
All
Yeah,
right.
go check it out.
All right, I'll be right back.
Y'all live?
Mhm. If anybody has any questions, drop them in the comments and we'll be able to get interactive.
Do you think my friend's on here?
Possibly. There's 5 people watching right now.
Noelle, if you're here right now, hello.
We have a slight intermission, family stuff, and we'll be right back. How are you doing today?
Good.
Good. Yeah, I'm glad that we're cleaning it up. We're gonna look to try to find a different way to hook everything together,
Yeah.
so it's a little nice, neater, and there's less cross-wire chains.
Are you guys watching the live on the TV?
Yep, and then anytime a comment comes up, it pull right up over there.
Gives an idea.
888.
Yeah, I hate getting calls like that. I really do.
Don't we all? It interrupts what you're doing.
It's not even that, man. These people are mean, ruthless. It's not about like being interrupted, but it is sometimes.
Yeah.
It's just
If anybody has real complaints about telemarketers, drop them in the comments.
please, let's
One day I just want to pick
throw
up.
shade for a minute.
Yeah.
One day I just want to pick up one of those calls and be like, "Leave me alone."
You should just have fun with them and just waste their time and have fun doing it. You got a voicemail, so you're all good.
All right, great. So it's real deal, maybe.
Right, and they'll be mean and ruthless in the voicemail. I'm just playing.
No, man. Sometimes the nice that's fake, dude. That is the meanest that you can be.
I got him laying on his bed.
Cool. Okay, the shades.
Yeah.
All right.
Do you want to do that now while everybody's here or no?
No, I'm good.
Okay.
Confusion?
Don't worry about it.
Okay.
We're doing Caleb's window.
Oh.
Oh, the window. Yeah, we'll get the window.
All right.
All right, we got 6 people watching. Anybody has a question, let us know, and please describe what we're doing.
All right. Currently, we got a double trigger coil setup. For those of you that know, and those of you who are new here, we got 2 32 gauge triggers one in each, and we got 4 26 gauge strands, all hooked up parallel. And that's currently what's going on at 6.5 volts and 0.4 amps.
So I see
Currently,
that-
I'm working on setting this up. Sorry, Paige, go
It's
ahead.
fine. I see that you're learning new things.
Yeah. Here's Paige. Hi, Paige.
Hi.
Thank you, Paige. That's awesome. Thank you. All right.
And I'm behind, but I'm slowly catching up.
All right. So we got these
Yeah.
cool switches.
Very slowly.
Hardcore. And that'll turn our power supply at certain junctions on and off.
Peace.
Peace. Have a good day, guys. Bye.
Bye. Awesome.
Very awesome.
Okay.
I'm gonna put the cup down.
Just this battery right here is the fresh one.
And we got a fresh battery right here. You can barely see it. There it is right there.
Yeah, black on black. There we go. Now I'm looking
Sorry about that.
for a
There we
diode.
go.
I don't have any more. I didn't bring any stuff over from the other room, so I'm probably gonna have to go back and forth.
Oh yeah, for diode.
Well, I didn't
Well, soon.
factor in that the Hall effect sensor wouldn't reach
Got it. So you need the extension.
Let's see if we move it. Can we move it closer?
Hmm.
I want to line them up though. It's hard for me to have the perspective I need unless I'm at the right angle. Okay, that piece of wood is there.
Ah. How? Oh, the big square.
Yeah.
Okay.
But the shaft is through. All right. Is that going to be good? I wonder. No, that's not good.
No. Find right where it starts. Nice.
All right. I know that was awesome though. That was teamwork right there. That was just getting it right. All right, let's spread these wires out. Dang it. One, two. And all my clips here are getting worn out. So,
Yeah, on these clips. He's run
These
hundreds of experiments with these.
yeah, man. And sometimes I don't pick them up right away, and they get demolished. There we go. We don't want the diodes touching either. So we got two series running through this. This is a 4-filer coil. There's lots of ways to set this up. Okay, you can either have two parallels in a series. You can have two series. You can have one series, but the max amount of wire is 200 turns of 32 gauge wire. That's all that's in here. And since this rotor moves pretty fast, we're gonna see once we hook the Hall effect up and all the stuff to the transistor board down there. We gotta get that back on the table. Yeah, we're gonna see if that works. Do me a favor.
Yeah.
You turn off the power.
Yeah.
Thank you. All right. Now, do we want it up here? I want
Maybe on the wood.
yeah. So let's make sure we go right here and just take the sticky off and put it on there.
Mm-hmm.
All right. These are tip 42s, Darlington transistors, 100 volt, 10 amps. All right, cool. So power.
Right now we are hooking up the coil and the power source for the baby rotor.
Yep.
Anybody has any questions, drop them in the comments and we'll be interactive with you guys.
All right. the emitter. This hook is negative, and this is hooked to the one. This is the where it started. So I always go by where it starts, where the coil starts. So it starts here and it ends over there. So naturally the energy, the electricity is going to go in. So I think that's the positive and that's the negative. All right. So now we need to hook, I think it's going to be alright, so 1, 1, 2, 2. This one needs to be hooked to the collector. Alright, let's see.
Hey, anybody watching, if you want to drop where you're from, let us know.
Yeah, we're in Michigan,
We are in
Detroit
the
area.
Detroit area.
Yeah. No, the collector, dude. So my marbles here, it's the black one. I use my trifocals. Yeah, that's good. And then gotta hook it to the Hall effect sensor. And that, it's already hooked up. We're gonna see if we're just testing to see if it works, so we'll just do the one hookup for now. I got 2 transistor hookups on this one little knob for the black white for the base. Got 2 clips on the base little knob. It's like not even that big. I got 2 clips on it. Had 2 clips on it. Alright, so just like this battery right here. It's like that big.
Not a lot of space.
Right. So I don't know if that one was not couldn't. I mean, it could have not been hooked up right at all. All right. So it's this blue one. All right. So this is going to be one series circuit, 100 turns wrapped in series. Layer, 2 layers, basically. I don't feel right doing it like this anyway. It might be the coil.
You didn't hook this one up.
Not yet. Oh, that one. Is that 2? Did I say 2 on it?
Yep.
Oh. What is it up to? God, I'm nuts.
You said you got to hook this one up to the.
No, I just hooked it up to the wrong wire.
Oh, you're good. Well, that's what happens when you work with lots of complexity.
There it is.
And you're still actually very good.
You can see it jerking now. Oh, maybe that was just a moving. No, there's nothing there. Those triggers are working good though.
Oh, yeah, you can hear that.
Yeah, I don't know. I think there's something wrong with this Hall effect sensor. I don't know what it could be though. I'm not getting much reaction. Those are M52s.
Any suggestions?
It's now 8 volts, 0.7 amps. That other one I have is working really good. I think it's in there. But no, it's about the same size. The hole is a little smaller in the other one.
And read the name and read it out loud too.
Benjamin Stakely. I feel like that small one's too little with too big of a gap. This one?
Yeah.
No, that gap is very small. It could be smaller though, you're right. Those amps are starting to climb. I'll turn this down. It's cool how this thing runs way better at like 6. Oh, you mean the 90 degrees? Or is it 45? 90, right? It's 90. No, there's definitely like something wrong with the Hall effect right now. There's nothing's happening. And I mean, what could be wrong with the coil is that it got melted.
You want to check the connection again?
Which connection? I mean, let's go from this. All right, this is the emitter. Let's see if this hooks up right. That, I can't believe I did that. So, emitter, dude. There we go. These wires keep on getting stiffer and stiffer, harder to work with.
Benjamin said, "Oh, okay, yeah, that is possible."
Let's see. I think I just might have blown the transistors. I didn't really know what was on. They're old. No, they're not. Alright, I'm gonna swap out those transistors. That was me turning it up a little bit. See what I mean? It sounds sick when you turn it up. Turn it down to like 6.5 volts and it's smooth sailing. It's about the same speed for both of those. So I'm gonna turn it off now. And we're gonna said swap transistors.
Yep.
Yeah, these aren't even hot. Maybe they're okay. I don't know. But I'm gonna swap them for some fresh ones. You know, I gotta redo the power distribution. That is gonna be very long and very tedious. But I will. All right. Let's see here. Yeah, I don't know about this one right now. But that's fresh. One, you know.
Mm-hmm. You can hear it humming.
Yeah. Mm. Yeah, I don't know about what. I mean, I think it's gotta be the Hall effect. I have two more that I can use. But I'm just wondering if I want to change the coil altogether. Because that coil probably will only work really well on magnets that are this size and not that size. So let me look in this box real quick. I have it over here. It's the one I was using before. It's 28 and 26 gauge. The one it's melted. This is how I figured it out, man. BLA just cannot withstand the heat of prolonged use. Alright. So, could you cut the power, honey?
Yeah.
I'm losing. I already lost it. Right. We'll leave these in series. I'll just move this over here. Alright, we're down to our last little bit of glue. Oh yeah, that's not gonna work. You know what time it is? No? Okay. I'll look in just a second. See, now that hole is a little bit smaller and there's a little bit more copper in here. And that air gap is pretty sizable. Let's move it in just a little bit. Alright, so this is the power source right here. This one is going to go in blue. Let me see if I'm right about this one. Yes, okay, this is power as well. Yes, yay! It's gonna be a good. This. There. Transistor. And we need collector. Keep on setting this thing up wrong. This should be the collector. Yeah, man, it's probably gonna work. I need the rest of the glue for that. All right, so brown. So this is going to go on this one. We're going to go here. I'm just thinking about how I'm going to hook the base up. That's this one.
For those of you remaining, if you have any questions, just drop them in the chat box.
All right, so look real quick. There. Let's see if that works. All right, now just need to close up. Yeah, this is not gonna work. That might work. All right, let's see. Yeah, that's gonna work.
There it is.
Bam, that was crazy. That was crazy. I've never had that much trouble before.
Boom shakalaka.
Amen.
Drop a like.
Drop it. Be attuned to the struggle. You know, it's all fun and games. Let me leave it at that. Nobody's gonna get hurt. That's 7.5 volts and 1 amp. Yeah. All right, now there was something about something that I read in my comments about. No, it's all right. I'll read it again. I'll figure it out. Yes. Oh my God. Look at how well that works. The 26 and 28. That's awesome, man. That is so sweet. Oh, like to, yeah. Thanks, Benjamin. Thank you very much. Yes. As you can see, we swapped out the coil. Good call on that. Nope, it was definitely just the coil, and maybe I had the coil wired wrong. Hall effect is good. Yeah, I've had a lot of trouble with the 50 turn 4-filers, but I like used that fundamental foundation, that diagram to make different coils that have worked wonders for me. It worked great. So the actual 50 turns with four strands hasn't worked for me yet. I don't have, either my rotors are too slow or something like that. I think this one could move fast enough.
The baby one.
Yeah, I think that one. I think that's what's in my head about what I read. Oh, you guys, I was thinking about making an aluminum pancake coil, because I saw this experiment where they had an aluminum plate, right? And then they had a coil, and they put electricity through the coil, and that coil would jump. It would like levitate. Now, if we get all that in a controlled environment, and we get that oomph enough, I bet it would keep on oomping. Up and up and up and up and up and up.
Okay.
But you got to get that in a controlled environment. The environment's got to be like sealed, but it's got to be at the same time interactive with the environment around it. So that it's complicated, and I don't know if we can do it with any current materials. I think we need to develop something different, an alloy of some kind, combination of metals. Do we have aluminum and copper? Do we have an aluminum copper alloy?
Maybe. That I'm not sure.
That'd be pretty cool, I think. Okay, we're up to 1.3 amps.
Ooh, is that what that might be what it's called?
Maybe. I think it's like a lens law or something like that. I don't know. I've only seen it in my head, dude. That's it. I mean, if it's out there already, good. Man, that would be
Drop
awesome.
a link. Yeah.
Drop it. You know what I mean? Drop a link. I want to see it. But yeah, something that would not necessarily jump, but just repel in that environment, like an artificial ground that you keep lifting off of. So naturally, in order to do that, you would have to have the aluminum pancake coil attached to the rotor itself, and it would be spinning with the rotor. And then you would have a pancake coil made out of copper attached to the bottom of your rotor. Okay? And then you would spin that, turn it all on, and see what happens.
Interesting.
Does it have to be a pancake coil of aluminum? I don't think so. But that would be cool, so I'm going to try it.
I think that's awesome. If you guys are enjoying the conversation, drop us a like, subscribe. We're going to be doing more lives.
I think that's going to start melting soon. That's a lot of amps.
Yeah, probably.
So I'll turn it down to like 4.5. like the gyroscope jump drive. The military contracted someone to try. Huh. Neat. Well, yeah.
That sounds like something military would be involved in.
Of course. And I'm gonna hook it up to my motorized tricycle,
Yeah.
and I'm gonna be at the red light. You know, I'm gonna hit the little switch, and the skull and crossbones gonna drop down, and I'm gonna fly away. Except it's gonna be like steampunk. You know, it's gonna be like,
Yeah.
you know, it'll be ghetto. It'll be jerry rigged.
That's funny.
Look at that. That's running at 4.5 and 0.3 amps. That's awesome, dude. That's pretty low for a trigger coil setup. All right, what do I want to do with this? We got this far. Now, what do we want to do? Any suggestions? Let's look around the table and see what we have here. We have 25, or no, this is 32 gauge, 22,000. Oh yeah, heck yeah, dude. Well, it's not necessarily a scooter, man. It's more like a motorcycle with 3 wheels. All right, so, yeah, let me look at this. Cool, I got an appointment. Not now, but soon. We got the 32 gauge, 22,000 turns in this beast.
Woo!
22,000. This will generate some volts, but it generates a max of like 20 milliamps.
Okay.
Okay, we got that. We got mini Bedini coil. This has got 6 strands of 26 gauge and 1 strand of 28 gauge. I had it hooked in AC series, and it was weak sauce.
Weak sauce.
So we're gonna
That's one of my pet peeves, man. Weak barbecue sauce. And you can tell. Because there's no barbecue taste.
All right. So we got those 2 coils. We got capacitors up the wazoo. We got 10 volt capacitors. We got 2.5 or 500 or 2.7 actually
Where's the 10 volt at?
in the bag.
Oh yeah, right there. There's the 10 volters.
Yep. And there's a 25 volt that's hooked up. It's not hooked up. It's just down there on the ground. My bad. So we got that. I am going to be making a coil with this wire. This is 1mm wire basically. It's 18 gauge. All right. Got bridge rectifier. Got several of those actually. So we can convert AC to DC. So, yeah, I'm trying to generate some current more than voltage. And I was told that the thicker you go, the better your chances are with that. And I think that I just think that little rotor with the speed that it's going will generate a lot. And 52 magnets on there. And we'll generate some stuff. Oh yeah, my copper pancake coil. Gonna make it out of this stuff. 12 gauge speaker wire. Yes, it is insulated and bifilar already, so that's awesome. But it's stranded. I mean, there's probably like 120 strands wrapped together to make that 12 gauge. This is dope. This is subtle. I mean, I gotta get rid of all these wires, man. I can't. The connectors are just insane. Once you get everything hooked up the way it's supposed to be, it's like, what the hell? So, you know, I got things that I can use. Yeah, I mean, I got terminal blocks, so I can use those. Let's get a quick reading here at 4.5. 300. Nice. Says 1384. $13.87.
Yep.
Wow, that's over 1,000 RPMs. It doesn't seem. Maybe it is. Holy cow. Let's see if this is. Seems like this one's slowing down a little bit. I will definitely write that down. I don't have anything like that right now, though. Sounds like a neat idea, the downward spiral. All right, now I would like people to check out a channel that I think is pretty cool. It's just starting out. Peter Hall Effect 2.0. It's awesome. All right, cool. Actually, we're gonna wrap it up. I'm gonna break it down with the conclusion, and that'll be that. So we got our trifecta coils, which are trifilar. 4 parallel strands are hooked up. 2 triggers are hooked up. One's set, one's offset. So we're getting twice the torque and speed for half the voltage. Awesome.
Mm-hmm. 29 to 50.
That's right. This bad boy is 666 turns of 28 gauge and 26 gauge.
And it's definitely used.
Yeah. Got it going fast and just on and off so much.
Lips are sealed.
See ya.
Have a good day.
Bye now. Thank you. All right, so
You
this
just-
is awesome.
Yeah, you just described this one.
Okay, so we're at, yeah, this one's being run by Hall Effect. This one's being run by the Trigger Strands. Awesome. Tip 42, transistors. Like I said, we're here. So there's 6 transistors hooked up right now. 4 of them are hooked up to the trigger wire, and 2 of them are hooked up to the Hall effect sensor. Bow down. Now, we're gonna wrap it up, but we think we're gonna continue from this point on our next stream, and we're gonna keep building. I have tons and tons of coils, man, just all different kinds of stuff. I'm gonna break out some of them, but you know, like, I gotta put them away. So that's, you gotta do that. All right, but thank you very much. Peace out. Please subscribe. Have a good day. Hit the notification bell and share if you want other people to see. Thank you very much. Bye now.